Okay, so how's everyone doing? Good? All right, homework went okay last week?
Yeah.
Questions?
Just a quick question. Do you pass back our homework or it's yours?
I pass it back, generally. Or, I don't know. But if you want it back, you can make a photocopy and turn in the copy if I mean if you want to hang on to it this week or something, you know. There's something exciting happening that requires your homework. I don't know. Okay. So I know some students are already a little bit worried about what's going to happen in this class and things like that. So just I don't know. Maybe not to ease some of your concerns, but also give you a reality check. So some of you guys have already hired tutors and things like that. If you're going to work with a tutor, that's great. What I strongly recommend is not to do your homework with the tutor, okay? In my opinion, that's a waste of time and money, okay? Because I think you learn the most when you do the homework by yourself, okay? When you do homework with someone who knows what they're doing, the homework suddenly becomes super easy, and it's like, oh, I understand everything, okay? And in my opinion, what that does is you learn less, okay? And that means you're essentially paying someone money so you learn less during your tutoring session, okay? That doesn't make sense to me. So what I recommend is you do the homework on your own, and then if you're going to meet with the tutor, you know, as you're doing your homework, okay, I've created the videos and the solutions for you guys. So if you get stuck on a problem or you're confused, you know, why did the professor do the homework this way? Or, you know, how did we get to this? I didn't quite understand this. Highlight those things and then ask your tutor those questions. And then ask your tutor to make up additional problems similar to those homework problems. And that will give you more practice, okay? If you're going to bother spending money on a tutor, do that. And of course, you don't need a tutor if you're doing just fine. So, but I know some of you guys were already worried about that. But okay, I hope the homework went okay. Thank you for turning it in and making nice piles right there. That's great. And then when I pass them back next week, there will be 4 piles again. So you can just pick up your homework from one of those 4 piles. Okay. Questions from last week's lecture or anything like that? Yes? Homework is fair game. So if there was a question in the homework and the concept was covered in the homework, then I feel like it is fair for me to put a question like that in the test or quiz or something like that. Okay. All right. Okay. Well, let me ask you a few questions about what we covered last week. Okay. So why do we study statistics? Okay, to understand life. Okay, that's why we study anything, right?
To understand the data.
Huh?
To understand data.
Okay, what is it about data that we want to understand? Yeah.
To make conclusions.
Okay, to make conclusions based on our data. Okay, yeah. Draw conclusions on limited data. Okay, great. All right, and in order for us to draw any kind of conclusions from limited data, we first have to be able to what?
Study information.
Study sample taken from the group.
Okay. I think what I was looking for is we first have to be able to describe our data. We have to describe our data, okay? And I heard the word sample. Okay, so what is a sample?
Select group we actually study.
Okay, select a group that we actually study. Okay, you're just reading off your notes, and that's fine, but that's good. Okay, what does it mean that we have a select group that we actually study? What are we talking about here? How is that different? So, is this classroom a sample?
Yes.
No.
Yes.
Well, that question, the answer depends on what am I trying to study. Is this, you guys are a sample of what? Students, okay. So if we were to say this classroom was a sample, what would the corresponding population be?
Extension.
Okay. Maybe. All right. Statistics students. Okay. So the population, it depends, but it could be, this class could be a representative sample of maybe extension statistics students, okay, students who take Stats Excel 10 through extension, okay, this could represent something like that. I mean, you guys are a sample of college students, so so technically a corresponding population could be college students. However, you guys would not be a representative sample of college students, okay? Because you guys, well, all college students ever, we've got colleges across the United States, across the world, okay? You guys clearly do not represent I don't know, well, we do have international students, but you wouldn't represent students from a, you know, a university that's not in basically Los Angeles here, okay? So, so how we pick a sample to represent our population is something interesting. Okay, what are variables? Yeah. Differences? Okay, I think that's the concept of variation. But what is a variable in and of itself? Yeah. A characteristic of basically our data. Yeah. So when we gather data, I said the columns are variables. What are the rows in our table of data?
Case.
A case. Okay. So every time we gather data and we look at a case, we've got different variables, basically describing that case. Okay, so I could pick a particular student. This student would be a case, and all of the attributes about this student, whether the student is male or female, the student's age, the student's well, I already said male or female, student's hair color, student's classes, whatever they're taking, whether he or she wears glasses, those are all different variables. Okay, so what kinds of variables do we have? We've got numeric variables and categorical variables. Okay. So how do we display categorical variables?
Like what type or what kind?
Okay, so a categorical variable tells us what type or what kind this particular case is, but how do we summarize a categorical variable? Okay, a frequency table. A frequency table. And what goes into a frequency table?
The category and then how many times?
Yeah, so summarizing a categorical variable. So it's always kind of funny. You guys have all just been sitting here and staring at me, and then as soon as I put something on the board, you guys start writing. But okay, so let's just talk about so summarizing. So this should already be in your notes. Okay, summarizing a categorical variable. We use a frequency table. And it might be something like sex, count, male, female, 20, 28, total of 48, or something like that, okay? This is how we summarize a categorical variable. Okay, how can we graphically summarize this? With a graphic.
Histogram.
Not a histogram, but a bar chart. Bar chart, okay. Now a histogram and a bar chart do look similar, but what's the key difference? Yeah, histogram is for numeric data, and the axis across the bottom of a histogram is the number line, okay? So you can't rearrange the number line. With a bar chart, the axis across the bottom are just labels, and we can rearrange them. If we want to put them in alphabetical order, fine. If we want to put them in order where we put the largest category first and the smallest category last, that's also fine. If we want to just do some arbitrary ordering that we happen to like, okay, we can also do that, right? Colors of the rainbow, we can go red, orange, yellow, green, blue. Why do we pick that one? Who knows? Yes?
If we choose to put it in numerical order, will it still be a bar chart?
It's still a bar chart, okay? Just by the very virtue that you get that you have the choice to put it in whatever order you want, that makes it a bar chart, okay? Histogram, looks kind of like it, except the axis along the bottom is our number line. We have no option on rearranging those ones, okay? That would be, we'd be breaking rules there, okay? Yeah, so that's summarizing categorical variable. What about summarizing a numeric variable? Okay, so we talked about one tool. One is the histogram, and this is a graph that we can use. What's another type of chart that we can?
The dot plot.
The dot plot. Great. Okay, and then later on today we'll learn about a box plot. Okay, and then summarizing a numeric variable. What do we want to talk about? Okay, so for a categorical variable, we talked about making a frequency table, and basically we're using counts. And then the other thing that we could also use that goes along with this to make it a relative frequency table was what? Percentages or proportions, right? Proportions. Yeah, we can also put in a column proportion. Okay. I just made up some numbers there. Okay, summarizing a numeric variable. Okay, so this is what we are going to spend today focusing on. Is we are going to summarize numeric variables. Okay, and we've talked about histograms and dot plots last week, but this week we'll also talk about using basically numeric summaries for numeric variables. Okay, so with a numeric variable, numeric variables can be summarized with numbers. Okay, and usually there are a few traits that we want to describe. Okay. Traits are attributes to describe a numeric variable. So we want to talk about the center, the shape, the spread, okay, and then optional, anything unusual. Unusual features. Okay, so again, when I'm talking about a numeric variable, we have to imagine that we've got some data collected, okay? So we have data collected and we're looking at this one particular attribute, okay? So let's say we're looking at our classroom. This classroom represents a sample. I've got 60 students or so. And we're looking at a particular attribute. So I could ask all of you, you know, tell me your age. And some of you will say, I'm this old, and I'm this old, and I'm whatever. Or I could ask another numeric variable. What's another numeric variable that I could ask of you guys? Your height. Okay. Anything else? Weight. Okay. Some students might not want to respond, but things like that. Okay. I can't ask your gender because that's not a numeric variable. Okay. So anyway, so just imagine. Imagine I've got a small. Maybe I'll just take like the first 2 rows of students here. Okay. Or so I picked 10 random students. 10 students. and I ask, ask for a picture. And so let's say the responses I got, I got 21, 18, 3, 5, okay, so here I've got 10 students, and okay, so this represents these 10 ages that I selected, or these 10 students, along with their corresponding ages. This represents my data set, right? Okay, so let's say, so just imagine I've got some statistics class that meets on Saturday mornings, and I've got 10 students enrolled, okay? And then so someone says, oh, you know, tell me what your students, describe basically the class of 10 students, all right, to someone else. How can we describe this class of 10 students? Huh? Okay, so I've got the ages of these 10 students. So yeah, someone's just telling me, you know, what kind of, you know, how old are the students in your 10 in your class? Okay, so rather than saying, oh, well, here are the 10 students, and I'm going to give you all 10 ages here, okay, which is one way to describe it, but that's rather tedious. What's a better way? We can summarize this. Yeah.
You can say like the average.
Okay, so I can talk about the average. What else?
Well, I was gonna say how many are under 25?
Okay, so we can start talking about, you know, the number of students under a certain age. Okay, yeah.
You can visualize it through a histogram.
Okay, so I can create a histogram. Okay, but if I'm talking on the phone, it's going to be hard to describe a histogram on the phone. But yeah.
You can also say there isn't like a large variation of age.
Okay, so there's certain things that we can. So let's say, you know, how can we describe the ages? Ages of the students in the class. Okay. So you guys have mentioned some things, and I'm going to say, when we are going to describe a numeric variable, which this is, the age is a numeric variable, there are things that we want to talk about, okay? We want to talk about the center, the shape, the spread, or any unusual features, okay? So these are the things that we're going to want to describe or mention when we're trying to describe the ages of students in the class, okay? So one thing that I heard you guys say was we could talk about the average age. Okay, so you have a question?
Median and mean.
Okay, yeah. So those are ways we can talk about the average. Well, what the average represents okay. So what would you guys say is the average age? 20, 22, something. Okay. So when we talk about the average, okay, this is a way to describe the center, okay? And there's two ways we can describe the center, okay? Generally, when you hear the word average, this corresponds to the mean, okay? Usually, and the mean tells us about our center, okay? But the center can also be described with the median. Okay. The mean is the balancing point of our data. And the median is our central point. Half of the points are larger than the median. Which means how many are smaller than the median? Half are larger, half are smaller, okay? I think a lot of you guys already know how to calculate the mean. How do we find the mean?
You divide by the number of.
Yeah, so the mean we find by add up all the numbers and then what do?
Divided by all the numbers.
And divide that sum, divide the sum by the number of numbers. Okay? So in terms of formula, we write x bar is the symbol for mean. So the mean has a symbol and that's x bar. And we say x bar is equal to the sum of our x's divided by n. Okay? This thing that looks kind of like an E or a sideways M, this is the Greek letter sigma, which represents sum. Add all up. Add them all up. Add up each x, meaning add up each number that we have, divide by n, which is the number of numbers. Okay? Let's back up. Okay? Each x, each number, and n is the number of numbers. Alright, some of you guys hate formulas, some of you guys love them, and some of you guys think you like them, but actually don't know how to use them. Okay, so for whatever reason, yeah, I don't know, students think like formulas are magic, and when I say you can have a note sheet for the final exam or the test or something, they write formulas down and then come test time they look at it and they have no idea what to do with it, okay? Just, if you know that the mean is add up all the numbers and divide by how many numbers you have, just stick with that, alright? There's no sense in confusing yourself. But these things are kind of shorthand ways of telling ourselves this means add up all of my x's and divide by how many I have. The median, on the other hand, how do we find the median? Yeah.
Put them in order and then you go through the middle.
Yeah, so I've got to put them in order, put the numbers in order. And then what? I find the middle number. Now the middle number, or the median, is the number What is n? Huh?
The place
The number
in
in
the
the
set.
Variable.
N is the number of numbers, okay? So the n that I had up here is the n that I have here. N is the number of numbers, okay? So in my data set, what is my n? 10. I've got 10 students, each with an age. I've got 10 numbers here. So I've got 10, and if I did 10 plus 1 over 2, what do I get? 5.5. Okay, so in this case, the middle number is the number in the 5.5 place. Okay, so let's put that on hold here, and let's figure this out. Okay, well, all right. So pull out your calculators and tell me what the mean is of this data set. All right, it's a race. If you can beat me, I'll give you bonus points on your homework. For real, I don't think you can beat me. 22.2. Oh, we have a winner. What's your name? Amanda, your last name? Probably did it beforehand while she was paying attention. All right. Okay. Your last name? Langford. Okay. I'll can you turn in your here? Oh, I got Lauren Langford. Okay. Well, all right. Amanda Langford. All right. All right. I'll give you bonus points. Amanda Langford. All right. Good job. All right. So there we go. That's our mean. 22.2. We add them up. We got 222 is their sum. We divide by 10. Our mean is 22.2. That serves as my mean. Okay. So here for our median, I've got to put my numbers in order from smallest to largest. Okay. So I'm going to do 19, 19. So let me just check these off. Then I got 20, 20, 21, another 21, 22, 23, 25, 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I've got 10 numbers right there. They are now in order. And so I'm going to find the number in the 5.5 place to get my median. Okay, so now these are in order. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if we arrange these from youngest to oldest, these two, this is the order. So this is my 5th place number, and this is my 6th place number. Okay, so if I did n plus 1 over 2 and I got 5, then my median would just be this number right here. But here it says it's the 5.5 number, so my median is the number in between the 5th place and 6th place number. Okay? My 5th place number is 21, my 6th place number is 21, so what number do I have at 5.5 place? 21. Okay, so that's simple enough. Alright? If these numbers were different, I would just take the mean of those two numbers. So if I had 21 here and 23 here, I would do 21 plus 23 divided by 2, and I would get 22 as my median. Okay, does that make sense?
Yeah.
So just take the, if you're getting a 5.5 place, if you've got a half place, basically you go in between the numbers that it specifies. All right, so that's how we get the median. Okay, and so if I draw a line at 21, indeed, what do we say the median was? It is our central point. Half of the points are larger than the median, and half are smaller. Indeed, we see we've got 5 points larger than the median, 5 points smaller than the median. Okay. What does it mean that the mean is our balance point in the data? What do you think that means? Huh? Tallest? No, it's our balancing point. Okay.
The average.
Well, the mean is the average, but all right. So what I mean by this? Okay, let's make a dot plot here. All right. Okay, so let's say this is 20, so a dot plot, I gotta put dots. So imagine these are stones or something, okay? And I put a dot at each point that I have in my data. Okay, so this is my dot plot, right? Good with this? What the mean represents, so just imagine this being a seesaw, okay? And I've got the weights on the seesaw like this. If I wanted the seesaw to be in balance, where do I gotta put the little triangle, the fulcrum?
In the middle.
Okay.
Yeah.
Well, the middle, what is the middle, right? The middle, if I say, oh, well, here's 32 and here's 19, the middle would be somewhere right here. If I put the thing here, this would not be in balance, right? It would tip over like that. Yeah.
I feel like you'd have to put it in the middle of the first half.
The middle of the first half?
Because it has more.
Okay, so middle of the first half. So the first half, according to this, is 21. So the middle of the first half would be over here. And this would fall over like that. Okay? Well, what I mean by the balance point of the data is the mean. If I put the triangle right here at 22.2, this is where it stays balanced. Okay? The mean is where our weights will be balanced. So that is our balance point here. This is the mean. Does that picture make sense? Yeah. Okay. If my median is at 21, okay? So this is the spot where half are larger and half are smaller, but that's not the mean, okay? Now, let's say our oldest student was not 32. But let's say our oldest student was 37. Okay? What happens? It shifts. Okay, it gets a little bit bigger, okay? Yeah, it shifts up to 22.9, exactly, okay? This thing would move over here, okay? Does the median change? No, the median still stays the same, okay? The last number is 37, but my median is still the number in the 5.5 position. It's still 21, okay? So what we have is that, okay, the median is not affected by extreme points. Meanwhile, the mean does take extreme points into account, okay? So here we can start to describe our class's ages, right? So on the phone I could say, oh, the median age is 21. The mean age is 22.2. Okay? Now, if you hear that the median age is 21 and the mean age is 22.2, what does that tell you? Does that tell you anything?
That there isn't a large
They're all about the same age.
But they're not. They're not all about the same age. Okay. No, okay, so we got the mean is 21, or I mean, the median is 21, and the mean is 22.2. So we have a case where our mean is larger than our median, okay? And when the mean is larger than the median, that usually means you've got some extreme points or some points that have shifted the mean away from where the median is, okay? Because if we talked a little bit about shape last week, right? Okay. And what we had symmetric, and what else did we have? Right skewed and left skewed. Okay. So is our data symmetric, left skewed, or right skewed?
This is right skewed.
Right skewed. Why is it right skewed?
This is so
Majority on the left side.
It's right
The pink is
skewed.
on the left side, that's why.
It's right skewed because I've got some student ages that are more extreme in terms of being larger than the rest, and no one who's more extreme in terms of being much smaller. Okay, so I've got, sure, the average age might be 21, 22-ish, okay? I've got a student who may be 10 years older than average, but I don't have any 12-year-old students in the class, okay? Because that would be the equally extreme in the opposite direction. So what, in general, when the mean is greater than the median, okay, the data is probably skewed right. Okay, if I have data that's skewed left, how do you think the mean and the median would compare? The mean would be less than the median, okay? So again, in general, if the mean is less than the median, okay, the data is skewed left. And if the mean equals the median, it's probably symmetric, okay, most likely. So we're starting off. We're starting off describing our data. We've talked about basically the center. This is the typical age of the students in my Saturday morning class, where only 10 students are enrolled. Okay? So I've got 10 students enrolled. Typical age is 21. Or if I want to use the mean, typical age 22.2. Okay? But if I did talk about the mean being 22.2, I actually have how many students younger than the mean? I've got 7 students less than the mean and only 3 students above the mean. Okay? But the median, I've got the same number below as I do above. Alright. We've already talked about the shape, right? Last week we talked about shape, and we said, what are the terms we can use to describe shape?
Bimodal, multimodal, uniform.
Okay. So we talked about the center. We either use the mean or median. And we talked about shape, symmetric or skewed, or unimodal, bimodal, unimodal, or something else. Multimodal or uniform, right? Alright, so how would you describe the shape here?
Skewed to the right.
Okay, so we talked about skewed right. And what else would we use to describe it?
Unimodal only has one peak.
Yeah, okay, and where's their peak?
The 20, 21.
Yeah, okay, so, I mean, we've got 3 ages here that show up twice, okay? But that's fine, okay? That's, they're all together, okay? It's not, I don't have any, like, gaps in between there. So basically, 2021, that's 19, 20, 21, that's my peak, okay? This is the most common age category, or age group in the class, or older students are a little bit less common, at least for this classroom of 10 students. So, so to describe this, we would use the, we would say unimodal skewed right for our data set there. Let's talk about our spread. So if we want to describe the spread and ages of our 10 students, how would we go about doing that? Alright. Well, some of you guys just kind of, not arbitrarily, but you guys kind of just threw out the idea that, oh, most of the students are around the same age. Okay? And that's kind of true. We've got a lot of students who are 19, 20, 21, and we've got a student who's 22 and 23. But then I do have students who are, 25 and 32, which is not close to the other ages as much. Okay? So we want to talk about basically, are all of our students' ages very similar to one another, or are they a little bit different from one another? And how can we effectively describe this, okay? Now, anytime you get into describing things, people can emphasize different things, right? You can ask someone, you can ask a person, describe someone's face to me, and they might highlight certain things. And then you ask someone else, and they might highlight different things, okay? So, if we're going to use, like, words to describe this, maybe we'll get some different descriptions here. But there's certain numbers that we use. So the mean is a number that describes our center, and so is the median. And we've got numbers that can describe our spread. We have a question.
Well, I'm just gonna ask. Spread. If we say like that most of the data is they're in their 20s, or from the average that most are in their early 20s, would that be a description?
Yeah, that's a fine description. Okay. I guess so. You can describe things, and I'm just going to equip you with some tools that you can use in describing sets of numbers here. Okay. So for spread, we want to basically we're asking, are all of our numbers similar to each other? Okay. Similar, basically similar in value to each other. Okay. Or are they quite different? Are they quite different from each other? Okay, so we have a few ways to describe spread.
Standard deviation.
Okay, that is one way to describe spread, yes. Okay, and we'll learn about these things, okay? So maybe we'll start off with something very simple. And one way to describe the spread is the range. Okay, and the range is equal to the largest point, or we call that the maximum, minus the minimum. So what is the range of my data points here? It's 32. The largest data point that I have is 32. My smallest data point is 19. So I have a range of 13. Okay? So the difference between the youngest person and oldest person in this class of 10 students is 13 years. That is the range. Another way to describe spread is with something called the IQR, which is the interquartile range. Inter meaning between, like the interstate freeway, it connects states. So quartiles, we're splitting up our data into quarters. Quarters, okay? So we've got the first quartile and the second quartile and the third quartile, okay? So Q1 is our first quartile. And this is the place where 1/4 of the data, 1/4, is smaller. And so if 1/4 is smaller, how much is larger than that point? 3/4, okay? So 1/4 is smaller. Okay? So Q3 is the third quartile. How much do you think is smaller than the third quartile? Three-fourths is smaller. Okay? So the first quartile is where 1/4 is smaller. The third quartile is where 3/4 are smaller. Okay? What about the second quartile? Okay? And we have a name for that? The median. The median. Q2 is equal to the median. Q2. The second quartile is the same thing as the median. Because that's where 2/4 or 1/2 is small. Is that alright? Okay, so this value 21, this is my median. Okay, or also Q2. How can I go about finding the first quartile?
Divide by
4.
Divide by 4.
The second and third.
Okay.
Second and third.
So basically, I'm going to take, so the median split my list of 10 into 2 parts, right?
Right.
I've got the upper half and the lower half.
Right.
So basically, to get where my quarters are, I'm going to take this lower half and I'm going to split it in half again. Okay? So how can I split? So now I've got 5 numbers. How do I split this in half?
Find the mean of that.
Okay, find the median of this. And where's my median of this one?
20.
20. Which 20?
The 3.
The third place number, okay? This is going to be my Q1. Yeah? What is the Q3 over here? Q3 is 23. Okay, so to find our quartiles, we first find the median to split our list into 2 smaller lists. And then from there, we take each smaller list, or each of the half lists, and we find the median of those half lists to get our quartiles. Okay, so to find our quartiles, we first find the median. And then we split our list. We then find the medians, the quote-unquote median of each half list. Okay. So the median splits our list into 2 parts. I should say, we first find the median. Okay, this splits our list to 2 half lists. Okay, and then we find the median of each half list, and this gives us our quartiles. Yes?
I'm not that sure what you mean by 1/4 is smaller when it says next to the first quartile. Do you just mean it's like the first fourth?
It's the spot, okay? If I draw a line at 20, okay, 1/4 of my data is smaller than 20, and 3/4 of my data is larger than 20, okay? Just like when I drew a line at 21, half of my data was smaller and half was larger. If I draw a line at Q3, 3/4 of my data is smaller and 3/4 are larger. I mean, 1/4 is larger. Okay, so what is my IQR?
3.
Yeah, my IQR is the difference between Q3 and Q1, okay? So the IQR is equal to Q3 minus Q1. So in our case, it's 23 minus 20. And I have an IQR of 3. So my range is 13. That's the largest point minus the smallest point. But my IQR is only 3. Okay? And this is the difference between the third quartile and first quartile. Okay? What percentage of my data is in between Q3 and Q1? 50%. 50% of my data is in between Q3 and Q1. Can you guys see that?
Yeah.
Yeah? Anybody having trouble seeing that? Okay. All right, what percentage of my data is larger than Q3? 25%. Okay. All right. Okay. Good. Okay, so let's just try. I'm gonna just throw up a bunch of numbers on the board, and then and I'm gonna just have you guys find the mean, median, range, IQR, just quickly. Okay, so let's just, yeah.
Right there above the IQR, does it say we find the median of each half list?
Yeah, we find the quote-unquote median of each half list.
Yeah, you put V's on median.
Oh, we find, sorry. Thank you. We the people, alright? We the median, okay? Of course, that's what I meant. Independence Day in a couple days, so celebrate America. Our rebellious forefathers founding our nation. How old is America turning? Happy birthday, America, right? Huh? It's 1776, so 237 years old. Not too bad, not too bad. All right. Let's see here. Okay, so here's 12 test scores, okay? And let's say we had 5, 9, 62. Ha ha ha. Okay. Okay. answers up on the board. Oh, did I screw that up?
Yeah.
Sorry. 72.5.
Wait, what is
Alright, 100% everybody?
No.
No? Okay. Questions?
Yeah, I think I understand how to get the Q1, Q3, but Ryan, how to get the IQR?
Alright, okay. Alright, okay. So who got all 5 answers?
I got 4 on that.
Okay, alright, good. Okay, 4? Alright, okay. That's about as much participation as I can expect. Okay, so the median. I got 12 numbers, right? What is step 1?
With the median, does it matter if they're in order from?
Yeah, it definitely matters, okay? So step 1, which I already did for you, was put the numbers in order from least to greatest, okay? So number 1, numbers go from least to greatest, okay? Step 1, already done, okay? Okay, how do I find my median?
Add 72 and 73.
Yeah, 12 plus 1 divided by 2 tells me it's the number in the 6.5 position, right? N plus 1 over 2. I've got 12 numbers, so I do 12 plus 1 over 2, 6.5. It's the number in the 6.5 position, so I go 1, 2, 3, 4, 5, 6. This is the 7th place number, so my 6.5 number is the number in between 6 and 7. So I do 72 plus 73 divided by 2, and I get 72.5. That's my median. Is that questions?
You can do it one more time.
What did you say after you said the number between 6 and 7? What do you?
Yeah, so my median is these, it's not 6.5, but it's the 6.5 place number, okay? So my 6th number is 72. My 7th place number is 73.
Okay.
So 6.5 is the number in between here and here. So I did 72 plus 73 divided by 2, because that's going to give me the spot halfway in between 72 and 73, right? And that gives me 72.5. Yay. Alright, is that good? Alright. Okay, so Q1, how do I get Q1? So now that I got 72.5, I split my list into 2 pieces, or 2 parts. And now I have to find the median of this, right? So how many numbers do I have now? I got 6. I go 6 plus 1 over 2, 3.5. 1, 2, 3, and 4. This is my 3rd place number. This is the 4th place number. So it's the number in between 62 and 65. Okay? So for this, I do 62 plus 65 over 2, 63.5. Good? Q3, I do the same thing. 80 and 85. 80 plus 85 over 2 gives me 82.5. The IQR is defined as Q3 minus Q1. Okay? That's just the definition. The IQR is the difference between Q3 minus Q1, so I do 82.5. Here, alright, this IQR is equal to Q3 minus Q1. 82.5 minus 63.5 gives me a difference of 19. If I did my mental math correctly. And the range is the max minus the minimum. So I do 93 minus 55, 38. Alright. Is that good?
Yes.
Good. Alright, so we look at the ages, when we looked at the ages of students here, we saw the range was 13 and the IQR was 3 years, okay? When we're looking at our test scores, we see a much bigger range, okay? There's a range of 38, and then the interquartile range is 19, okay? So if I ask what percentage of students have scores in between 72.5 and 63.5, what percentage of students had scores in between 63.5, which is Q1, and the median 72.5? What would you say?
25%.
25%, 1/4. Okay. What percentage of students had scores higher than 72.5? 50%. Okay. Because the median is 72.5. That means half are larger, half are smaller. Q1 is 63.5. Okay, so that means 3/4 are bigger, 1/4 is smaller. How much is in between Q1 and Q3? The middle 50%. Okay, so the middle 50% is encompassed by that. All right, so these are numbers that we use. Okay, the IQR and the range; those are ways to describe the spread in our data. Okay, and so if we see a set of data with an IQR of 19, and we see another set of data with an IQR of 3. That tells us that this set of data has numbers that are more different from one another than this set of data. This set of data has numbers that are more similar to each other, okay? If we look at the range, it tells us another thing, okay? But the range is affected by extreme points. So, and we saw that with the oldest student being 32, that significantly affected our range. The IQR tells us where the middle 50% lies. Okay. So these are all good ways to describe spread in a data set. Okay, and then there's one more, another way to describe spread in a data set, and this one is a vital key concept. Okay, and it's one of those terms that you've heard, but you're not really sure what it means. And this is the standard deviation. Standard deviation. Okay. This is another way to describe spread. Okay. So the IQR and the range describe spread. Does Q1 and Q3 describe spread? Not in and of themselves. Q1 just tells you where the 25th percentile is, and Q3 tells you where, the spot where 3/4 are smaller. Okay. But the IQR gives you an idea of basically the range of the middle 50%, and then the range tells you where how big of a difference from the largest to the smallest point is. So those give you an idea of spread. And standard deviation, again, this is another way to describe spread. In another number, another way to describe spread. Spread or dispersion or variation, okay? If a number has a large standard deviation, what does that mean? Or not number, if a data set has a large standard deviation, what does that mean? It means it has large spread. Okay, that data set has a lot of spread. And what does it mean? Okay, and this is what we've been getting at. Okay, what does it mean for one data set to have large spread and another data set to have small spread?
More variation.
More variation. What's another way?
A skew a certain way.
Huh?
It's skewed to the right or left.
The skewed part doesn't actually come into play yet, okay?
Yeah,
The
it means
skewed
bimodal.
that doesn't tell us, so when we're talking about spread, it doesn't tell us about the shape, okay? It doesn't tell us if it's skewed, it doesn't really tell us if it's unimodal or bimodal, okay? So spread tells us about spread, okay? it tells us, are the numbers similar to each other, okay, or are the numbers very different from one another, okay? So you could think about, so in a college class, and if I asked you what your ages are, there's going to be a decent amount of spread. Not a whole lot, but a decent amount, okay? Because we've got students who are just out of high school, students who, you know, took a few years off, maybe went to, you know, served in the military and came back to school or things like that. Okay, so we've got a range. You know, we've got some students who are 19 or 18 and some students who are in their mid-20s, and then some students who are coming back to school after many years away, okay, in their 40s or things like that, okay? So there's quite a bit of spread in terms of ages. All right, just imagine, let's say we went to an elementary school and we picked out one classroom, okay? What are the spread in ages they're going to be like?
Very little.
Very little, right? At most, we're going to have a student who was held back a year, okay, and that student is like a year older than everybody else. But if we pulled out like a 3rd grade class, pretty much all of the students are going to be like 8 years old, 9 years old, okay? Maybe we have a precocious 7-year-old or something like that. But pretty much we have a very little spread in, if we take one class of 3rd grade students, right? So if we looked at the IQR there, it'll be tiny. It'll be like 1. If we looked at the range, it'll maybe be 2, okay? And if we looked at the standard deviation, it's probably going to be a small number. If we looked at the ages of this classroom, okay, the range will be bigger. The IQR will be bigger. And the standard deviation will also be bigger. These are all just different ways to measure spread, okay? And each of them has a different thing, okay? So we're just talking about, are the numbers similar to one another, or are they vastly different, okay? So let me just thought process here, okay? What group will display more spread, okay? Okay, are you guys familiar with the honor guard in the army? No? Okay.
Sure.
Or like the tomb of the unknown soldier? Okay. No?
Yeah.
Come on. All right. So a little bit of patriotic history here. Okay. So you know, America has been at war for many years in its history. Okay. But there's a military tradition and pride in there, and so we have soldiers that are designated to do like military funerals or these very high these events where their purpose is not to be fighting but to look sharp and represent the military to the public eye. Okay, I mean they've done their service in terms of combat and things like that a lot of times, but their role is to look sharp. So they have very stringent requirements in terms of how tall you can be. Okay, you can't be a short person in the honor guard. Okay, you can't be overweight. Okay, they have very strict requirements on how tall you are. You know, your waist size, your chest size, all of these different things. And recently they started allowing women to serve in the honor guard, but they also have to fit certain requirements. Okay. On the other hand, when we're talking about the military as a whole, okay, basically if you can pass the physical requirements and you're willing to serve, they'll allow you to serve. So if I asked which are we going to see more spread in terms of heights in the honor guard, or more spread in heights for the general military? What is your answer? General military, we're going to see a lot more spread. Okay. What about ages in honor guard versus ages in the military?
Some more spread in the honor guard.
Regular military.
Okay. So that one is tough to say, but probably we will see more spread in the general military than in the honor guard. Okay, I don't think there's any age requirements for the honor guard itself, but in general, the people serving in the honor guard are within a certain range, whereas in the military you've got a much, I don't know, you got people who've been in the military for many, many years. They're career soldiers. But that one's, it's tough to say, and actually the difference in spread probably will not be as great, okay? So, what else? What else? Okay, well anyway, I want you to get comfortable with the idea of spread here. Okay, what about this? Will we see more spread in, no, I can't do it. I can't phrase the question in such a way. All right, but we, basically spread, this applies to what kind of variable? Numeric variable. Do we have spread for categorical variables? No. Okay, we don't have IQR, we don't have standard deviation, we don't have range for categorical variables. We can talk about variation in categorical variables, but this idea of spread and the range and the IQR and standard deviation, that does not exist for categorical variables. So these terms only exist for numeric variables. Okay, so standard deviation, it's another way to describe spread, okay? A definition of the standard deviation. The standard deviation is the square root of the variation, okay? Is equal to the square root of, and I'm going to put in, here, I'll just write, of the parentheses statistical variation. So a lot of times we'll just say standard deviation is the square root of the variation. But the word variation has so much meaning in the English language that I've got to specify the statistical variation, which kind of has a specific meaning. Okay, statistical variation is a number. Okay. Another definition of the standard deviation can be thought of as the typical difference between a point in the data and the mean. Point of the data I'm starting you off with all of these kind of just word definitions, okay? And then we'll get into the calculation. But what I found is that if I go straight to the calculations, you guys get lost in the calculation process, and I don't know, it loses me. So let's just take a few of our students here.